Very good morning. Myself, Dr. Assistant Professor of Department of Electronics and Communication Engineering at the Institute of Technology. This is my second lecture on topic of transistor. As you know that it's a three-terminal semiconductor device. So, uh, in previously we just gone through the two-terminal semiconductor device like p-n junction diode, Zener diode. Now we have to enter the three-terminal semiconductor device. So transistor is nothing but the transfer of resistance or impedance from high impedance to low impedance. It having a three-terminal device, emitter, base, and collector. It is also known as the bipolar junction transistor. Why it is called bipolar? In transistor, we got the current due to the flow of majority and minority carriers, means flow of electron and flow of hole. As a result, we got the current. So that's why it's called a bipolar junction device. So before we enter the basic of the transistor, few comparison and few parameters that we have to know with that of normal p-n junction diode. A definition, simple definition in diode is a two-terminal semiconductor device which allows current in only one direction. So the symbol of the diode is also shown here. Definition of transistor is that the transistor is a three-terminal device which allows current to flow from high resistance or high impedance to the low impedance. Here basically PNP or NPN means there is two junctions formed. So these two junctions is known as high resistance and second one is known as the junction 2 is known as the low resistance. So the current is passed through from high resistance or high impedance to the low impedance. Formation basically formed by joining of two type of semiconductor, p-type and n-type semiconductor in p-n junction or in Zener diode. In transistor, basically there is a p-type is sandwiched between two n-type, or an n-type is sandwiched between two p-type. Means PNP and NPN types are formed. This is the symbol of a NPN transistor is shown here. Also, we can define compare the by depletion layer, number of junction, terminals, and there are finally applications of the diode and transistor is like that. A depletion layer, for in case of when we compare to the depletion layer, only one depletion region is formed for the p-n junction diode. But for transistor, there is two junctions, so means there is two depletion layer is formed. Number of junction in p-n junction, only one junction is there, p and n. For transistor, npn and pnp means there is two junction is formed. It's a two-terminal device diode, and transistor is three-terminal, emitter, base, and collector. It can be applicable for diode in a switch, and transistor is also applicable in switch and as an amplifier. So rectifier diodes are used in half-wave rectifier, full-wave rectifier, bridge rectifier, also in doubler, clipper circuit and clamper circuit. For transistor, it can be applicable in amplifier and oscillator, etc. So the term is that the bipolar junction transistor, already I have told that the term is called the bipolar. The current passes through, or whatever the current we got through the transistor, that is due to the electron and holes. So it means involvement of electron and holes, both the charge carriers are involved. So that's why its name is also bipolar junction transistor. Basically, it's two type NPN and PNP. Means N type semiconductor and P is P type semiconductor. So that's mean P type is sandwich between two N type is called NPN, and a N type semiconductor is sandwich between two P type semiconductor is known as the PNP. Basically, according to the semiconductor types, it's NPN and PNP type. So this is the basic construction of a transistor is shown here. Emitter, base, collector, and substrate is there. So according to the type of, if it is NPN, then if it is PNP, on that basis the types of materials are used. So basically, what is the function? If I know these three terminals, it's a three-terminal device. So emitter, base, and collector. What is the function of this emitter? The function of the emitter is to emit the charge carrier. If it is PNP, then majority carriers means holes are the charge carrier. If it is NPN, then electrons are the emitted from the emitter terminals. So the basic function of this emitter is to emit the charge carriers from this terminal. And then collector. The collector terminal is collecting the charge carrier, whatever generated or emitted from the emitter and passes through the base, that should be collected in the collector terminal. And the third terminal is the base. Base is nothing but to control between the emitter and collector. It's a control terminal. The flow of charge carrier from emitter to base, emitter to collector through base, that is controlled by the base terminal. The flow of electron, flow of holes, means as a result the flow of current is controlled by the base terminal. So also there is a few basic difference of these three terminals, emitter, base, and collector, on the basis of doping. So as it is known that the function of emitter is to emit the charge carrier. So by default, its doping concentration in emitter region is high with compared to the base and collector. Whereas after the emitter terminal, the collector terminal is moderately doped, and the base terminal is lightly doped. Because the function of the base is to control the charge carrier and current in between emitter and collector. That's why the doping concentration is lightly. Otherwise, it will be, there is no junction. That's mean that leakage should be, or current automatically passes through the emitter to the base. That's the emitter to the collector. So that's why the concentration of the base region is light or so small with compared to the emitter and collector. Also the width of the emitter, base, and collector is different. As we see in the previous slide, the construction of the transistor is that the collector region is wider, means width of the collector region is higher with compared to the emitter and base, because the function of the collector is to collect the charge carrier which is emitted from the emitter and passes through the base. So that's why the width of the collector region is higher, because when charge carriers is passes or collected in the collector region, so many heat will be generated. So that heat should be dissipated in the collector region. If the width is higher, means it can be easily dissipate the heat. So that's why its width is higher with compared to the emitter and base. Then after the size of the width of the after collector, the emitter region width is lower with compared to the collector, and base width is minimum with compared to collector and emitter, because base is nothing but to control the terminal terminology or control the flow of charge in between emitter and collector. So this is the symbol of these two NPN and PNP transistor. Here is a significant is that the arrow. We gone through the symbol of the two type of transistor NPN and PNP. It can be easily visible that in the emitter terminal, the arrow is given in the emitter terminal in both cases, but the direction is opposite. If I consider for NPN transistor, the direction of arrow is given from collector to the emitter, and for PNP, it's from emitter to the collector in this along this direction. If we bias NPN transistor, emitter base is forward bias and collector base is reverse bias condition. So during that time, electron will flow from collector to the emitter. Means flow of electron is from emitter to collector to emitter to the collector. As a result, the direction of current is from collector to emitter. So that's why the arrow is given on the emitter terminal is from collector to the emitter. That is the significance of the direction of the arrow, and it is given in the emitter terminal because the charge are emitted from the emitter terminal, majority carriers, electrons or hole for NPN and PNP. So that's why the arrow is given in the emitter terminal for both cases, for NPN and PNP. Similarly for PNP, if we go through the arrow is from emitter to the collector, means PNP, emitter base forward bias and collector base is reverse bias. At that condition, so it can be seen that the holes are flowing from emitter to the collector. So that is the direction of current. As you know that the direction of flow of hole and the direction of current is same. So that's why the arrow is given from emitter to the collector direction, and it is situated in the emitter terminal. For both cases, the arrow is given in the emitter terminal, but according to their biasing, the direction is different. So this is a symmetric representation how the emitter are emitted and collector collected, and base terminal is that is control the flow of current in between emitter to collector. So the biasing of the transistor is shown here. Basically, the emitter base terminal is forward bias and collector base is reverse bias. So during that time, what happened in that condition, when emitter base is forward bias for both NPN and PNP. Here I have considered the NPN type transistor. So emitter base is forward bias means the emitter terminal is the negative one and the collector one is the positive. So NPN, so N type means majority carriers are electrons. So electrons are negatively charged and the emitter terminal is negative. Whereas compared to that, the collector is positive terminal. So electrons will automatically they will attract towards the collector region. So that's mean the flow of electrons will towards the collector, and in between their base region is there. So base region is plus. So in base region, the holes are the majority carriers. They will move towards the different direction along this N type and P type. Means the width of the depletion region is reduces. So as a result, the flow of current is increases. So that's when electrons from emitter to the flow of electron from emitter to the collector. So as a result, the current is flowing in the just opposite direction from collector to emitter, which is shown in that just bottom of the figure. So the total current, whatever the current we got from that from the transistor, that IE emitter current, that should be sum of the base current and the collector current. So the current direction and the is given here actually. The total current IE, that is emitter current, is equal to the collector and base. It can be also explained through that the function of the emitter is to emit the charge carrier. It should be passes from base, and collector is to collect the charge carriers. So from that concept of correction and generation, also we can explain that, we can write that, we can prove that the total current IE equals to the sum of the collector current and the base current. So basically, there is three operation region in BJT or transistor. That is cut-off region, linear or active region, or saturation region. So on the biasing condition, these three regions are formed basically. In cut-off region, in emitter base and collector base are reverse bias condition. During that time, this whatever we got the output, that is the cut-off region, means during that time, if we gone through the biasing condition, emitter base is forward and collector base is reverse bias, no charge will passes from emitter to collector or collector to emitter through the base terminal. That's mean as a result we don't get any such kind of current. So that is called the cutoff region. Means we basically during that time it's act as a off state. We don't get any current during that biasing condition. That is the cutoff region. In active region, when emitter base is forward bias and collector base is reverse bias condition. During that condition, the charge will flow from emitter to collector through the base. Base act as a pass filter. So that's why during that time we get current. That is the active region. In saturation region, when both emitter base and collector base are forward bias, during that time we get a amount of current. It's linearly increases. That is also known as the saturation region. If we go on through the VI characteristics, that can be easily visible that three regions are formed. One is cutoff, that is there is nothing current we got, and then saturation linearly increases, and the active region. Okay, on that three different biasing we got that three different region. There is an application of these three regions is that this is the cutoff, active and saturation, whatever I explained. The cutoff region is known as the off state because during that time the current is through the transistor is zero. So that way it's also known as an off state. Nothing we get during that time. In active region, basically this region is applicable for the amplifier, and saturation region, this is known as an on state. So that's mean on state means during that time we get a current according to that biasing. So the transistor can applicable as an amplifier and as also as the switching. As we know that the switching having on and off state, that cutoff region and saturation region, these are the off and on state. And also the active region, it can be also performed as a amplifier. So these are the applications of whatever I have explained, that the transistor is a switch. Basically in cutoff region it's act as a switch. In saturation, that is cutoff region, that is the off state, and in saturation this is the act as a on state. Amplifier. So as we know that the it can also use as an amplifier. as we know that the amplifier, to amplify the input to the that of output. So the circuit diagram of amplifier in common emitter configuration. So means we can use the transistor as amplifier in three different modes: common emitter, common base, and common collector. The term is known as the common, means the terminal which is shared by the input and output terminal. So that's why the name is the common emitter, common base, and common collector. Here I have considered that transistor as the amplifier in common emitter configuration. So it can be visible that the emitter terminal is common both input and output. So amplifier means to amplify, means whatever we are applying the input, the output should be more than that. So it can be clearly visible that input signal is given there and output is from there. So that is the amplified, means more than that of input. So that means the transistor can also use as an amplifier in different applications. So these are beyond the transistor. These are the three more transistor like junction JFET, junction field effect transistor, and field effect transistor, MOSFET, metal oxide semiconductor, field effect transistor. These are also the different types of transistor that will be explained in the next lecture. And thank you for your kind attention.